Hello everyone, welcome to another episode from CADXL. Today I am going to talk to you about the existing of electrons inside an atom. Now the electrons are always there in an atom. So what we have learned in grade 9 or year 9, 10, 11 is that electrons are present outside the nucleus, which is correct, and we have learned that they are present or they exist in a circular pathway, or they have an orbit which is in a circular pathway, which is not exactly correct and which is not wrong either. So when it comes to the A level, we have to learn how actually electrons are present inside the atom. So what you have learned in grade 9, 10, 11 or in IGCSE is a basic representation of electrons in an atom, right. So if I can teach you that part, or if I can tell you like this part like this. Now let us take a common example that most of us know, most of you know, assuming that all of you have heard about the Baker Street in London, about the Sherlock Holmes stories. I am not from London, but if I am taking the example where I live, you might not get it. So let us take the Baker Street, assume that you do not know anything about that. So let us take the Baker Street in London. If you meet someone and you go to the Australia, and let us say you meet someone in Australia, and let us say you are from England, and if someone asks where are you from, you say I am from England. But if you meet another British person even in Australia, you do not say you are from England, then you probably say you are from London. If you meet someone in the London, then you do not say that you are from London, you might say that I am from the Baker Street. So it is like this. So electrons are present outside the nucleus in a circular pathway is something that you tell to a person in Australia that you are from England. So electrons are present in outside the nucleus in circular pathway. Yeah, in a certain extent that is correct, but not exactly there, because scientists have found outside the nucleus they have electronic shells, we call them as quantum shells, and scientists have found each quantum shell or each circular pathway we draw, they have sub energy levels, or we say them as sub shells. So it is something like that you are from London. So London is in England, that is correct. So subshells are inside the main energy levels or inside the quantum shell. So each quantum shell you have sub energy level or subshells, we can easily say, and then inside each subshell you have a 3-dimensional space where we can find an electron. That 3-dimensional space where we can get the electron or we can find the electron is called as an orbital. So that is something like the Baker Street. So if I just go back to that example, quantum shell is like the England, subshell is like London, orbital is like the Baker Street. So actually electrons are present inside the orbitals, which are present inside the subshell, which are present inside the quantum shells. So example wise, Baker Street is in London, London is in England. It's like that. So electrons are present inside the 3-dimensional space, and it is called as an orbital. Now there are different quantum shells, you know, the first electronic shells, second, third, fourth. Depending on the main energy level or the main quantum shell, we have different sub energy levels or subshells. We call them as S, P, D and F, and each subshells has a different number of orbitals. So we will see how many orbitals can find in each subshell, right. So this is the basic idea. Electrons are present in quantum shells, actually present in orbitals, which are present in subshells, and those are present in a quantum shell. So if we come back to that subshell part quickly, I told you there is something called a subshell. In a subshell, we do not have to know why it is called as SPDF rather than simply ABCD. You do not have to learn. So I just go what you have to know, SPDF. Inside the S subshell, we have S orbital. So what is an orbital? Orbital is a 3-dimensional space where electron is found with highest probability. So, if I draw a dot, right, this dot represent an electron, this dot represent another electron. So, if I draw a dots, the s subshell or the s orbital gives the three-dimensional space where you can find an electron. Anywhere in this place you can get an electron. So, this is what looks like an s orbital, like a spherical shape. So, we say the shape of s orbital is spherical, right. Anywhere inside the sphere you can find an electron. So, when you go down first main energy level, second main energy level, you have s subshells in each. So, s subshells are present in all quantum shells, right. In all quantum shells you have a subshell. So, when you go down the group, the radius or the size of the sphere gets increased, or other way around, the size of this three-dimensional space would increase. So, this is the s subshell. Then there is something called p subshell, we have to know that as well. So, p subshell has a shape like this. If I draw a dots again, so it is like this, each dot represent an electron. So, it is like this, we call this as dumbbell shape. That is what we say, dumbbell shape. So, these are three-dimensional space. So, even this s orbital or the subshell, right, you can have three axes, x axis, y axis and z axis. Normally we say this is x axis and this is y axis, and when you write in chemistry three-dimensionally, this Cartesian coordination. So, this is the z axis, the green color one. So, normally when you write it on the paper, we flip it like this. So, z comes in the place of y, x remains as it is and y goes backwards, or if I write it to the other way around, the y comes forward. So, like that. So, that is why x, y and z we write like that. So, in a s orbital it is the same, but p subshell we have three different orbitals per each axis. So, you have a s orbital like this, we can call it as p z orbital, you can have a s orbital like this, we can say p y orbital, and you can have a p orbital like this, we can say it is a px orbital. So, there are three p orbitals per each atom, p xz, p y and p x, but for s orbital you have only one shape. So, p z, p y, p x, you have three different orbitals. The combination of all these three orbitals gives you the p subshell. So, s subshell, p subshell, the other one are d and f. So, d and f, there are two other subshells like this, same as that, and the number of orbitals they have is also different. It is increasing in odd numbers. You have 1 in s subshell, 3 in p subshell, 5 in d subshell and 7 in f subshell. They do not expect you to memorize the shapes of d subshell because those 5 d orbitals are not exactly symmetrical like this. In d orbitals, I told you have odd numbers, so 1 s orbital, 3 p orbitals, 5 d orbitals and 7 f orbitals. The shape of these 5 d orbitals are not identical. Actually 3 of them are looks alike, but 2 of them are completely different. F orbitals are also completely different. So, I am not going to talk about the shapes of d and f, but they are also something like this. They are also a different place where you can find an electron, a 3-dimensional spaces. So, that is the basic thing you have to remember. So, the summary wise what you have to remember is electrons are present inside an orbital, and you have to remember the definition of the orbital in IGCSE. Then you have to remember S subshell, P subshell, D subshell and F subshell is there, and then you have to remember how many orbitals are there in each orbital. S subshell, each subshell. S subshell only 1, P subshell 3, D subshell 5, F subshell you have 7. Right. Now, having that, I will just mention how to remember what type of subshells are actually present in each quantum shell. So, we know that there are S, P, D, F, and we will see what are the quantum shell, let us say quantum shell type of subshell. In the first quantum shell you have only S, second quantum shell you have S and P both, third quantum shell you have S, P and D subshell, fourth quantum shell onwards you have S, P, D, F. So, fifth also S, P, D, F, right. So, I told you the total, let us say this axis, if I draw the total orbitals, S only 1, here 1 plus 3. So, total 4 orbitals are there in second quantum shell, here 1 plus 3 plus 5. So, total 9. So, here it is 1, here it is 4, here it is 9, then 1 plus 3 plus 5 plus 7. So, then you will have total 16, right. So, total 16 orbitals in only in fourth quantum shell. So, these are the number of orbitals you have. So, total orbitals are like that. So, this is what you have to remember. The next video I will explain how electrons are actually present or fill into these orbitals, and there we have 3 rules. So, that will be discussed in a separate video. So, this video will discuss about how electrons are actually present inside an atom, right. If this is helpful, give a thumbs up and consider subscribing. Thanks for watching.